Hey everyone, and welcome back to the channel. Today, we're diving into something truly spectacular. A story that stretches from the dawn of our solar system to the cutting edge of modern astronomy. We're talking about a comet, but not just any comet. This is Comet 3L Atlas, and thanks to the incredible James Webb Space Telescope, we've just peeled back its layers to glimpse its very heart. So, what's the big deal about a comet? Well, comets are like cosmic time capsules. They're frozen relics from the very beginning of our solar system, formed over 4.5 billion years ago. They are packed with the original materials, ice, dust, and rock that eventually came together to form Earth and the other planets. Studying them is like reading the first chapter of our own origin story. Now, Comet 3LATLAS is particularly special. It was discovered by the ATLAS survey system, which is designed to spot near-Earth objects. But what makes this comet fascinating is its journey. It's part of a family of comets believed to have originated from a single, much larger parent comet that broke apart centuries, maybe even thousands of years ago. Imagine a giant cosmic snowball shattering in space, with each fragment going on its own orbital path. Comet 3L Atlas is one of those fragments. Astronomers have long suspected this family connection because several comets share very similar orbits. Yes, like finding a group of people who look different but share the same last name and a common ancestor. The theory was solid, but proving it required something more. To confirm the link, scientists needed to analyze the DNA of these comets, their chemical composition. Specifically, they wanted to see if the amount of volatile ices, the stuff that turns to gas when warmed by the sun, was the same across the different fragments. But there's a problem. When a comet gets close to the sun, its ice sublimates, creating a huge glowing coma and a spectacular tail. This beautiful display is what we love to see, but it's a nightmare for scientists trying to study the nucleus, the solid core of the comet. The coma is like a thick fog that hides the tiny, city-sized object at its center. For years, the core of these comets has remained hidden from view. That is, until now. Enter the hero of our story, the James Webb Space Telescope. The JWST is a game-changer for astronomy, and this is a perfect example of why. With its powerful infrared vision and incredible sensitivity, it can do what no other telescope could. A team of astronomers, led by Michael Kelly at the University of Maryland, pointed Webb at Comet 3LATLAS. Their goal was audacious, to directly observe the water vapor sublimating from the nucleus, even when the comet was far from the sun and its activity was low. Think about how difficult this is. They were trying to measure the faint whiff of water vapor coming off a tiny, dark object millions of miles away, an object that was barely active. It's like trying to smell a single drop of perfume from across a football stadium, but Webb did it. The telescope's near-infrared spectrograph, or an IR-spec instrument, precisely measured the amount of water vapor being released, and the results were stunning. The team was able to calculate how much water ice was in the comet's nucleus. But they didn't stop there. They also used Webb to measure the amount of carbon dioxide and carbon monoxide, other key ices that tell the story of a comet's formation. Here's where it gets really exciting. By analyzing the ratios of these different ices, astronomers can create a chemical fingerprint for the comet. This fingerprint tells them about the environment where the comet formed billions of years ago in the protoplanetary disk around our young sun. Different materials freeze at different temperatures, so the ratio of ices reveals the comet's birthplace. When the team compared the chemical fingerprint of 3L Atlas to another suspected fragment from the same family, Comet 355P, they found a striking similarity. This was the smoking gun they were looking for. It was strong evidence that these two comets were indeed siblings born from the same parent body long ago. But Webb's observations gave us even more. By measuring the comet's activity, scientists could work backward to estimate the size of the nucleus. Even though they couldn't see it directly through the faint coma, the data suggested a nucleus about the size of a city block. It is amazing to think that this relatively small chunk of ice and rock holds such profound secrets. This discovery is more than just a family reunion for comets. It opens up a whole new window into the early solar system. By studying these pristine fragments, we can learn about the conditions that led to the formation of planets. We can start to piece together how materials like water and organic molecules, the building blocks of life, were distributed throughout the solar system. Some scientists believe that comets like 3L Atlas may have delivered a significant portion of Earth's water, and perhaps even the organic compounds necessary for life to emerge. Each comet we study is a piece of this grand puzzle. Before Webb, we could only get these detailed chemical fingerprints for very bright comets that passed close to the Sun. This created a bias in our data. We were only seeing the loudest comets, not necessarily a representative sample. Webb changes all of that. Its sensitivity allows us to study a much wider range of comets, including the faint, distant ones that have been out of reach until now. This means we can build a much more complete and accurate picture of the comet population and, by extension, the early solar system. We can now test if all comets from the Oort cloud, the distant reservoir of comets, share a similar chemistry, or if there's a wide diversity. The successful observation of 3L Atlas is a proof of concept. It shows that we now have the technology to systematically study the nuclei of comets and unlock their secrets. It's like we've been trying to read a book through frosted glass and Webb just wiped the glass clean. What's next? Well, the team plans to use Webb to study other members of this cometary family. By comparing the chemistry of multiple fragments, they can get an even clearer picture of the original parent comet. Was it a uniform ball of ice and rock, or was it a lumpy, heterogeneous mixture? The answer will tell us a lot about how these large bodies formed in the first place. This is just the beginning. As we use Webb to explore more comets, both near and far, we are bound to uncover more surprises. Each observation adds a new data point, a new clue in our quest to understand where we came from. We are truly living in a golden age of astronomy, where the mysteries of the cosmos are unfolding before our very eyes. The story of Comet 3L Atlas is a perfect example of scientific discovery. It starts with a theory, a hunch based on orbital mechanics. It then requires the development of revolutionary new technology, the James Webb Space Telescope. And finally, it takes a dedicated team of scientists to painstakingly collect and analyze the data to find the answer. It's a testament to human curiosity and our relentless drive to understand our place in the universe. So the next time you see a picture of a comet streaking across the sky, remember that it's more than just a pretty light show. It's a visitor from the distant past, a messenger carrying the secrets of our own creation. And now, thanks to the incredible power of the James Webb Space Telescope, we are finally able to read that message. What do you think is the most exciting part of this discovery? Let me know down in the comments. I'd love to hear your thoughts. And if you enjoyed this deep dive into the cosmos, make sure to hit that like button and subscribe for more stories from the frontiers of science. Thanks so much for watching, and as always, keep looking up.